if okay with you, Jim, I'd like to sort of introduce you to the community. Jim Taylor like to showcase his project recently, a use case of internal knowledge search using SK with Qdrant as the vector database, where he's written sort of content importers to pull in data from different sources like Outlook, SQL, video, file system, and different data sources. Yeah, so Jim, if you want to go ahead and share your screen.
Yeah, I'll get stuck in. Excuse the low tech presentation, but just if I just state the problem first, it's kind of the usual problem with in a busy consultancy. You have information in little silos all across your organization. So you've got the product team, we've got our own technical documents for our development work. We have the architecture team, keep all of their notes in Obsidian, which stores things in Markdown. People have bits of information they've collected in files on disk. We've got customer support emails, which might contain information that might help customer support people deal with issues. We have products, websites with information on, and internal help articles, some of which stored in SQL. So it's everywhere, and trying to get the whole business to kind of circle in on one source of truth for that, it's kind of impossible. So we wanted to find a solution to make it easy for somebody to just go and say, hey, I've got a problem, I need to find some information, go find it for me. So it's a very simple use case of, you know, grab all of the information, make it available via a web interface, and then put it into a vector database so that it can be searched. So we sort of got this notion of content source providers. They're just a way to extract content from file system sources. So we use Xseed and iTextSharp to read the text content from Word and PDF docs. Any text file formats immediately easy to use. We also have a lot of handover videos and training videos. So when the file system content provider encounters a video file, it will call an API and use transcription using Whisper. So it will get the transcription, and then we use GPT to actually clean it up so that we can remove filler words like that kind of thing. So we've got importers for Outlook, SQL, and websites. So we've got a web scraper using scraping B, and then we'll also in future be able to add connectors for Teams files and SharePoint lists. So I can just show we've got like a simple console app. Just way to add a content source. So I'm going to add a file system. I'm just going to copy that. Okay, a directory is added. I'm now going to run the embeddings for that, and I will show the code. So bear with. I've got a file system content provider. So all that's doing now it's processing is basically iterating through each of the files in the directory and getting the content. Usages. And we have this function here called build embeddings for content provider. And that is saving the information to the vector database here. But I suppose what I should show is the, oh, that's finished running. I should show what we've got running in the background is I've got this vector database here running in Docker, and we've got this collection here, which is where these files have been placed. So I've got, before I started, I've got this file system that I've just added, plus we've also scraped our Eva check-in product website. So I should now be able to run the web application and do a search on that. So I'll stop the console and go over to the UI. In terms of how we're using Semantic Kernel, we have a service that we use to build the kernel. So we just basically use the kernel builder from Semantic Kernel. And we wire up the chat completion service, OpenAI text embedding service, so passing it the configured keys, and then we wire it up to the Qdrant memory store. You can also swap this out for the Azure Cognitive Search memory store as well. So in terms of how we're using this, there's not much complexity to it. We have a system prompt, master prompt that we have, and the master prompt is, so along the lines of, you are an AI system that helps people find information from the search results, and then we just give it enough background and information to tell it about the types of information that it's dealing with, so it has enough context, and then we just tell it a few things. You know, don't need to mention your knowledge cutoff, no need to disclose that you're an AI, treat me as an expert, be accurate and thorough, only use the information provided in the search results. That's an attempt to make sure that it's grounded on the data. And then, you know, if there's not enough information, make some suggestions for better search terms. So the UI has come up. I can just do. All right. So you can see that what we've done here is the vector search has pulled back relevant documents based on the vector database search. So it's got like a relevance score there. Then if we want to, we can actually click through and link to the information that we are after, if the information here is not sufficient, we can go to the original source document. So in the case of a file system or an Outlook message, it will also launch the individual email message, or if that file system was from your system, it will launch the file on your desktop. So one place to go to find information from lots of different places. So yeah.
Cool. Yeah, so that connections to kind of different data sources and so on, that's kind of built in. You've already kind of provided that in the configuration.
Yes. Yeah.
Okay.
So it's kind of a simple RAG kind of application here. So when we get the answer, we do a vector search, we add the article text into the kernel, and then we basically stream the response back to the user. So the first chunk that we send back is the information about the articles that we found. And then the chat response that we get back from the Open API client provider is streamed back to the user. And then in the client side code, we open up a stream reader. So we basically do a fetch, we get the stream reader, we read the first chunk, which is the information about the articles, and then while the stream is being read, we're just basically outputting the answers as they go.
Yeah.
So,
perfect. Yeah. I think yes, I think just mentioned about you leveraging kernel memory, right, for this.
Yes. Yeah.
Yeah. Perfect. Awesome. Cool. Any questions from anyone from the community?
Yeah, I've got a question if I may. It's Glenn here.
Right, Glenn.
Jim, thanks for the demo. That's great. I'm interested in how are you orchestrating these different sources? So if a user's question is best served from one set of sources as opposed to another, rather than calling into all of your sources every time, are you using Planner in any way for that, or how does that orchestration work?
I'm not currently using Planner in a different branch to this. I have the notion of different collections of information. So the architecture practice might have their set of information. The dynamics team will have their set, and then the product team will have the customer support team for the product will have their set as well. And so at the moment, I've just got you as a user will probably know which kind of collection is appropriate to your role. We could in future have a general purpose kind of search, which is find anywhere and then use the planner to then search within a particular vector database collection. So the answer is not at the moment, but that's something that we could do using the planner.
Yeah, got it. That makes sense.
Yeah.
I can sneak in one more question. Hopefully my token count is not used up yet. Well, quickly, how are you managing cat history there? This concept that's been bugging me is this idea of an ongoing conversation with a user, where a user asks a question, your agent answers the question, but then the user asks a subsequent question that relies on the prior knowledge of the chat history. So they might use pronouns to say, yeah, okay, of those results, can you filter it down by X. Do you face that scenario at all?
Yes, that's at the moment. This is a one-shot search and retrieve. The next plan is that we actually treat each one of those as a conversation, and if you want to do a next search, you can basically click new and it will do a fresh search with a fresh set of context. So the plan is that when you call this at first, it will do the search, and then the follow-on conversations will be based on that. And then the plan is to look at get the kind of intent of the user and find out whether they're asking for different content or an elaboration on the existing information, or whether it needs to go and fetch more information to help that user's query. So it's a proof of concept at the moment, and we're looking at things like that as well, but that's how we're planning to approach it. So
yeah, I was just going to add on to Glenn's question and your answer. It's something that I don't have the answer either, by the way, but yeah, it's something I think about all the time, is that if you're using something like vector search, Azure search, to go and, I guess, query a whole lot of content which semantically makes sense, then it's easy then to go, or it makes sense to go and get the right bit, stuff in the prompt, generate an answer. But when you're going, and there's a couple of questions in the comments about it. If you're going and hitting like CSV or a database, for example, and converting a query converting a natural language query to a query, you're going hitting that database, or you've got multiple collections like you were just talking about, Jim. Yeah, that idea of maybe having a step first with a stepwise plan or something, which goes and hits a meta index or something to go and figure out where to go, because otherwise it's like the idea of doing Excel spreadsheets or CSV, like, how would you know which one to go to, especially when they're just numbers? So you need meta tags, memory tags, or another index to figure out which one to go to, and the search continues for an answer for that one.